if you want to know how to do ROM test, it is which is a non-volatile memory. So, you can check out how ROMs are implemented. We can either have this or not have it. Okay. So, we can either remove this transistor or have this transistor. So, that is how you can program it, right. If this transistor is missing, suppose we enable this row, okay, then all these guys are enabled, all these transistors, wherever there is a transistor it will conduct. Okay. And as a result we will get a 0 here, otherwise we will get a 1. Okay. If this transistor is missing, this this is pulling it up, right. This guy is getting pulled up because of this transistor. But if we have put this transistor and we select it, wherever the transistor is present, we will get a 0, wherever the transistor is not present, we will get a 1. Okay. So, that is the basic idea of a ROM. Can there be a fault in a ROM? Of course, there can be. Maybe that connections are broken or whatever, right. It can happen. So, we were intending to do it like this. But maybe this transistor this was open, then unfortunately we wanted to store a 0, but we ended up storing a 1. So, even in a ROM, when we mass manufacture, there could be errors. Okay. So, to test a ROM, what we could do is, see, there is no write in an operation, no write in a ROM, we only read. So, what we could do is we can read out the contents, we can use a counter here which starts reading out the data, right, and as the data comes out we can use an your miser will work out. So, you could use your multiple input signature register, right, and it can the signature can be used show whether or not there is an error. Okay. So, a good ROM where all the zeros and ones are the way they should have been, that will leave one signature which is the golden signature. But if there is a mistake in one of the positions, right, then we will get a different answer. See, let us take this example. There is a ROM with 4 addresses and let us say 4 bits. So, the miser we may have chosen something like this, it could be your Bilbo if you want. So, we have a 4-bit input and we could connect this output of the ROM. So, in the first clock cycle I may read out 1101. The Bilbo has been initialized to let us say all zeros through a reset, and as I read the Bilbo will keep giving a signature, right. At the end of all the reading out all the 4 locations of the ROM, I will have the signature. So, this is a good signature, and if one of them were to change, let us say from 0 to 1, then this signature is very likely to change. So, I will leave that as an exercise for you. So, take a ROM which is, let us say 8 cross 8. Let the contents be these are the contents. So, let us say the first location has hexadecimal, I will write in hexadecimal AB 01, C3 02, B1 03, A2 04 and CC. So, this is a content stored in the ROM, and then introduce an error. The erroneous ROM AB may have changed to A1 01, C3 03 and B1 may have changed to D1, then 03 may have changed to 01, A2 may have changed to B2, 04 may have changed to 05 and CC may have changed to CD. So, this is a bad ROM, this is a good one. So, use the LFSR 1 plus x power 4 plus x power 5 plus x power 6 plus x power 8, which we illustrated in the class. This should be the LFSR, sorry, the MISR polynomial, and find the signature and find the faulty signature. You can do this in Excel if you want, or you can do it with Circuitverse or something like that. Okay. So, I would encourage you to use both if you can, right, encourage you to use either Circuitverse and or Excel. Excel is, I guess, fairly straightforward, but it will be very helpful if you can use